Hello and welcome to part 2 of what if you continuously deduplicated your test code. In part 1 we did some simple deduplication of the asserting that the same text is not an anagram with 3 different variations. In fact, just looking at that, I'm sure the eagle-eyed amongst you have already spotted it. I still had the original description of that text. Same short text is not an anagram. This is now generalized over 3 examples. So we can just say same text is not an anagram, and we'll pump the 3 examples in. That small correction aside, the point about part 2 is let's start getting a little more extreme in our deduplication. And one area of deduplication that's quite easy to miss is a different category. It's not about something being exactly the same. It's about the purpose of something be the same. So deduplicating purpose. So let's think for a moment about the word same up here and the word down here. So, both of these purposes really is just to have a short valid word, nothing more than that. So there's no reason to list the constant. We can deduplicate that purpose of a short word by simply creating something like the word's not relevant to the test as well, so it adds a bit of value to tell you that it doesn't matter. It just matters that it's a short word. It doesn't matter that it's called same. Nothing's asserting on that word anywhere. And similarly here. So we deduplicated that little bit of purpose there, the purpose of that data. You can probably come across other examples of that as we run through. And we also have some duplication here inside this text of text 1. So really what we're interested there is deduplicating that argument name data, which is the same on both sides. So remember, sometimes deduplication is removing code, and sometimes it's removing the possibility of an ambiguity or a consistency. In the what if introduction, we talked about one of the propositions here was that deduplication gives you stable code and consistent code. It's code that if it works in one side, it works in the other. So if we want to make sure those text ones are always the same, then we do something like this. It actually helps when we start to write other test cases here and deduplicate them, as you'll see in a moment. So that argument name gets put in there, and also in here. So let's check that test is still failing, and the other one is passing. Okay, just missed my semicolon there. Good, and because we haven't implemented the null rejection yet, then we would expect it to be failing, and that's exactly what it's doing, and failing on the argument name text 1. So let's implement the minimum that can deal with that first failure, which is this. And I'm intentionally not going to pass the message through because I want to see it fail for the 2 different reasons before I trust that test, unless it's mandatory to provide a description there. Sorry, illegal argument exception. So what happens when you move between .NET and Java regularly? Start mixing up the 2 a little bit. Okay, that's fine. So come back to argument test and rerun that. We should find we're 1 step ahead now. So instead of failing, let's see, that's no longer required. Rerun those tests. So now the problem is not that it didn't throw the exception, so we now know our test is good up to here, but it's correctly identified that it's not giving the right parameter name in the, not giving the right argument name in the illegal argument exception. So here we would expect something like Text 1 is null according to our test specification, and should be that if we run that, good, we're in passing shape there for that one particular use case, which is great. So now we want to look at some others, and if you think about it, there's three possibilities here that we really want to exercise to make sure null's rejected. One is null followed by short word, or any word for that matter, but short is fine for this example, and short word and then null, and null. So we don't want to do the same thing we did in part one, which was duplicate it first and then remove it. The whole idea of continuous is you catch it the moment you know you want to duplicate something. And here you could quite easily copy paste this test and edit text one and get and edit the is anagram to different parameters and get the same result. But instead of doing that, we're going to deduplicate as we go along. And in order to do that, we just identify the test cases, which are pretty straightforward. If you think about it, each of those test cases are just involving a pair of values. And we can just pump in those pairs. It might be more elegant ways of expressing them, but for the moment we'll express them as just a series of two item arrays. So we've got our first test case there, which is null and short word. We have our second test case, which is short word and null. And we have our third test case, which is null and null. Okay, and for each of those, then really all we have to do is to build out our information here to support that. So now when we're looking at whether the argument name is text1 or text2, well, it really depends on where we've passed the null in. In this case, if we pass the null in argument 1, we'd expect it to be picked up. If we passed it in argument 2, we'd expect that to report on 2. So we can simply say here, if the first item of the pair, which is argument 1, is null, then we expect this particular test case to be reporting on item 1 and checking item 1. Otherwise, we expect it to be checking text 2. So that's pretty straightforward. Now we get the right argument name throughout, and we get the right assertions throughout, and the right comments. So the next thing is to make sure that our pair is being passed in here instead of the literals. So now we put in the first item in the pair and the second item in the pair. So far so good. So we haven't duplicated that 3 times. We've got our 3 test cases here, and we should be able to run those, and I would expect the second one to fail at least. The third one might pass, because if you handle the first argument properly as null, it will already return a null exception, but we'll just put that to the test now by running. Okay, so expected null exception for text2 is exactly what we'd expect, because in this case the second item there is null, and let's just implement the test that deals with that. We'll do it in 2 stages again to prove that our deduplicated logic is working well, because when you're doing this kind of work with tests to heavily deduplicate, you need to keep sanity checking that you're not corrupting the tests and creating false positives, because the tests are now going to be more complicated. You won't just be able to read them as flat structure and know whether they're working or not with the code review. You need to look at whether they are actually failing when they should and passing when they should. And the best place to do that is as you continuously deduplicate, you can get immediate feedback on whether your tests are still catching the things they should. So in this case, I've deliberately made sure that it's throwing the null exception properly this time, but throwing the wrong description, to make sure that the test is picking up that in my new deduplicated version. Okay, and that's correct. It's now moved on. It's not failing on the exception not thrown for text2. It's failing because the description is wrong. So now if I correct the description for the right argument and then replay the tests, I'm passing all of them. Now, one final sanity check I would usually do at this point is where I've got a test case where it's not obvious whether I would catch an instance where passing null in both parameters failed to return something on the first one. I'm going to fake a mistake there to make sure that part is caught as well in my deduplicated logic. And the way that I can fake that is pretty straightforward. So don't handle the exceptions if they're both null. That's a nice fault injection so that when I run this, I can pick up exactly what I expect. Expected null exception for text one, which is exactly what I expect on this third instance. Certainly it's the behavior I want in this case. All well and good. So coming back to here, I can now take that out with a bit of confidence that it's detecting what it should. It's not a perfect test for that test, but it's a pretty good one. And with deduplication, you have high confidence anyway, because you know that the handling for that try-catch and the messages and the exceptions is the same for every iteration of that loop. If they were all separate tests, you might need to test each one very carefully individually to make sure. The real reason why you're testing the tests inside this is to check that the generalized part of it is working. This bit that chooses between the 1 and 2, which is actually the interesting logic, plus the strings here. Okay. So we're in pretty good shape here, but as this is the part 2 and it's trying to look at more advanced things, we've seen the deduplication of purpose. There's another purpose here, is that here we've got two values and they are the same, they're just flipped. So if we look at reversing that, let's take an example if we do something like this. So we've got a concept here of an invalid pair. And one example of that invalid pair is null and short word, but the other one is just the reverse of those arguments. So if here we just put in our invalid pair, and here we create some kind of reverse function for that, again, I'm not looking for the most elegant way to do this or the overgeneralized way, just the basics of removing that semantic duplication. It's just the same data. Sorry, not semantic. The semantics are different. The semantics is that one of the values is null, but the implementation of that is which one is null. So we can do something like this. And for a real implementation of this, you would just use a reverse array, and there's a couple of 3 lines of Java code that would convert the array to a list, use the reverse functions, and return it. For simplicity, for this example, I'm just going to hand code the reversing, because it's really about the deduplication of concept here, not the mechanics of reversing an array. So now we've got the invalid pair, we've got the reverse pair. There's more duplication in this, but just before I come to that, let's see if we're still in good shape for the running tests. Yeah, still all passing. And just to check that the reverse pair can be tripped up, a quick sanity check. Let's pick one part of that reversed pair like that, and then run the tests again. And we should expect a fail there on one of the items. Expected text 2 is null, got text 1 is null. So that gives me confidence the reverse pair is working. You could even unit test your little helper functions there, and typically if they start becoming used by multiple tests, I would do that. But this is just a check to make sure that the test is catching what it should do after the refactor. So we're back to a running state. And what else have we got here? We have, again, on the extreme end of deduplicating continuously, we've got a couple of nulls here. And actually, we can extract the physical duplication of null and null and make it instead the concept of creating n of something. So if I look here, n of some string value and some number of items that we want in that string. And then that just becomes fairly straightforward. And right over here, we can just create that. Again, there might be array library ways of doing this. I'm just hand coding it so you can simply see what's going on. We want a 2-item string array to make up our pair. Now we guarantee that every item will be text. We're getting back to that consistency argument again for deduplication. Here we're not saving a lot of code. In fact, we're introducing more code. What we're making sure of is that if you ask for 2 nulls, you get 2 nulls, and there's not a possibility to get a null and something else, or 2 of anything, or n of anything for that matter. So return items. So now here we've got n of and null. And how many nulls do we want? 2 to make up our pair. That should be okay. Just close that up here. Okay. Let's run those tests. With all these experiment videos, we're taking it to the extreme so that it becomes hard to find any duplication remaining. There is some others though, because in this case, there's particular things we're looking for. So we're expecting expected null exception for a particular argument name. Actually, that's not what we expected here. We expected an invalid argument exception, and we expected the description to be something is null. Okay, that's fine. So I think that's fine for part 2. In part 3, we'll get on to another even more extreme example and look at other deduplication of purpose and generation of variations of purpose, which keep the duplication out of both the data and the unit test sets. Thanks for watching.